Welcome. In this video, we are going to see about physical properties of metals and non-metals. First, we'll see about metals. These are some example pictures of metals which we are using day-to-day life. Iron rods, iron pipes, copper wires, gold bars. So these are some examples. In periodic table, group 1 elements are alkali metals, group 2 elements are alkaline earth metals. As well as the D block elements are called as transition metals. That green color zigzag part are basic elements or post transition metals. So these are the metals are there in periodic table. Next, properties of metals. Metals are hard, shine, malleable, ductile, sonorous, and they are good conductors. We'll see one by one elaborately. First, metals are hard. Metal particles are closely packed together. They have very little intermolecular empty spaces. On account of the closed particle arrangement, metals have high density and are very hard in nature. For example, iron and aluminium. In picture you can see that aluminium sheet and iron chains. To indicate that metals are very hard in nature, these two examples are given. Next property, metals are shine. Metals have shiny surface because they have lot of free electrons on the surface. Due to that free electrons, metals have shiny surface. This property is called as lustrous. So aluminium sheet, copper wires and gold. So these are some examples to indicate that metals have shiny surface. Next property, malleable. Metals can be extended into thin sheets by hammering. This property is called as malleability. For example, 1 gram of gold can be beaten into thin sheets with an area of about 6.7 square feet. Initially, gold will be looking like this. By hammering, we can extend gold by thin sheets like that. This property is called as malleability. Next, metals are ductile. Metals can be drawn into thin wires. This property is called as ductility. For example, 1 gram of gold can be drawn into thin wire of about 2 km. Initially, gold will be looking like this. By drawing into thin wire, we can produce gold coils. And this is another type of gold coil. So this property is called as ductility. Next, metals are sonorous. Metals can produce sound when they are tapped with a strong material. This property is called as sonority. For example, in churches or in temples, we are using bells because metals can produce sounds when they are tapped with strong materials. This is called sonority. Next, metals are good conductors of heat. Due to the close packing of metal ions, metals can conduct electricity. Metals are very good conductors of heat. Because of that only, we are using metal pans for cooking. As well as if you are heating a metal rod by holding up, after some time you will be feeling the hotness at the another end, which means metal rod is conducting heat. So because of that only we are saying that metals are good conductors of heat. Next, regarding electrical conductivity. Metals can conduct electricity due to their free moving electrons. Metals are good conductors of electricity. For example, a copper. In our houses and all, we are using copper wires in electrical circuits because it is a good conductor of electricity. Next, we are going to see about non-metals. These are some example pictures of non-metals. Astatine, iodine, carbon, phosphorus, sulfur. So these are some examples of non-metals. In periodic table, except metals, all other elements are non-metals. Non-metals can be in any of the states of matter. They may be in solid state, liquid state or gaseous state. We'll see about the properties of non-metals. So non-metals are dull, brittle, poor conductors of heat and electricity. They are non-sonorous. We'll see elaborately one by one. First, dull. Non-metals are dull in nature. This property is called as non-lustrous. For example, red phosphorus, which we are using in matchsticks, as well as sulfur. So these are the two examples to indicate that non-metals are dull. Next, brittle. Non-metals are easily broken, cracked or snapped if it is in solid state. This property is called as brittleness, for example, carbon and sulfur. In these two pictures, you can see that the objects are cracked because they have fallen down. So this property is called as brittleness. So non-metals are brittle in nature. Non-metals are poor conductor of electricity. Due to that, they are used to seal the electrical wires. For example, plastics and PVC pipes are used to seal the electrical wires. So in our houses and all, the electrical wires which we are using in electrical circuits are sealed by or covered by plastics, as well as they are passing inside the PVC pipes. As the non-metals are poor conductor of heat, they are used to hold the hot cooking vessels. In this picture, you can see that the cooking vessel is made up of metal, but the holder is made up of non-metal, because non-metals cannot conduct heat. Due to that, they are used to make handles. Next, non-metals are non-sonorous. Non-metals do not produce sound when they are tapped with a strong material, or else they will produce very dull sounds only. For example, if you tap a wood log, you cannot get a sound because non-metals are non-sonorous. Next, we are going to see some exceptional cases. First, we are going to see about mercury. Mercury is a metal, but it is in the liquid state in room temperature. So this is how it will be looking like in the room temperature. Mercury is a liquid in the room temperature. Alkali metals, which means group 1 metals, are very soft in nature. They can be cut by knife. For example, lithium, sodium and potassium. In these two pictures, you can see that lithium and sodium are being cut by knife, which indicates that alkali metals are very soft in nature. Next, iodine and diamond are non-metals, but they are luster in nature, which means they are very shine in nature. In these two pictures, you can see that how shine they are. Next, about diamond. Diamond is an allotrope of carbon. Though diamond is a non-metal, but it is very hard in nature. Because of that only, there is a saying that diamond can be cut by diamond. Last exceptional case, graphite. Graphite also an allotrope of carbon, but graphite can conduct electricity. So graphite is nothing but the middle part which is there inside the pencil which we are using. Thank you for watching. We'll see in the next video. Thank you.